Welcome back, and this is Mr. Francois, and I'm giving you a little lesson on resistance rules. Yes, finally we are talking about fighting the power. No, not really. Uh, what we are talking about, however, is we're talking about resistors in series and in parallel and how to deal with resistances in general. So we have two rules for resistance. We have the resistance total and for series, and we have the resistance total for parallel. So we have two rules for each of these, one for series, one for parallel. Here's our rule for series. We can see it right there that it's simply just the addition of all the resistors that are in series. So if we look at our example here, we can see we have three 6-ohm resistors added in series, which when we combine them together just gives us 18 ohms of resistance. Now if we look over at parallel is the inverse rule, so you can see it's 1 over the total is equal to 1 over the first resistor plus 1 over the second resistor, and so on. So you have to be very careful about when you're putting this into your calculator. Put it in as the fraction, 1 over whatever it is, add them all together first, then flip it again because it's 1 over that total. Be very careful. There's a lot of flipping that you have to remember to do in here. So if we look at our example, we see that we have three 6-ohm resistors combined in parallel. So if you wanted to see what this equation looks like, it is 1 over 6 plus 1 over 6 plus 1 over 6 equals 1 over the total. So if I add these together, it gives me 3, 6 equals 1 over the total, which when I reflip it, that gives me the total is equal to 6 over 3, which is equal to 2 ohms, as you could see that I had right here. Now, let's see this in a more complex example, because we have to correctly identify what we're talking about. So here's an example. Here's a 6 resistor complex circuit. So we have to identify what it is that we're talking about. So what we'll do is we look at this circuit, and we want to figure out what's in an actual series, what's in actual parallel. Remember that being in parallel means you can be the only resistor on each branch from the branching points where they separate and where they meet back up. So if I was talking about this point right here where it splits up, I would be talking about this branch in blue, and then I would say that it's this branch in red, and we can only add resistors on that series if they are the only resistors on each branch for the parallel. So let's actually take a look at how I break this down. So first thing I identify is that these two, the 4 and the 2, are in fact in series with one another. Nothing else is possible. Okay, the 5 and the 6 here are not in series with one another because there is that junction, that branch point right there, which allows some current to go that way. But let's move on. So you add them in series and they combine and they add straight together and they give you 6. And I put a little circle around this resistor that you can see right here. Okay? Because I want to symbolize myself that this is not an original resistor. This came from somewhere else. This will be very important later on when we start resolving for voltage and current throughout the series. So then what I do is I look at this and I say, oh, okay, now I have these two in parallel with each other. Let me break them down and bring them together. So I can bring them together and I say, oh, okay, this is the equivalent of 3 ohms of resistance because of that 1 over rule. 1 over 6 plus 1 over 6 gives you 2, 6. Flip that again, it's 6 over 2, which gives you 3. But then, now you can kind of start to see the pattern. I see something else. I see the 5 and the 3. The 5 and the 3 combine, and that gives me 8 ohms of resistance right there. But now they're actually a parallel right there. The parallel can be brought together using that 1 over rule, gives you a 6 ohm resistor combined. And then you have 6 and 8, and they combine to give you 14, which is our total resistance, which is our end goal for as far as resistance goes. So this is what you want to do. You want to break down resistance. Be very certain of what is in series, what is in parallel. Remember, parallel rule can only be added if they are the only resistors on the line, like these two, each branch of this. So you have one branch here that has the 24 and only the 24 on it. You have one branch here which has the 8 and only the 8 on it. Those are the ones that you can combine in parallel. Series has to be a direct series. You can't combine the 8 and the 24 yet in this example because the 8 and the 24 are not in series with one another. There is a chance for the current to go somewhere else. If there's a chance for the current to go somewhere else, it is not in series. So, there is your review on what series is. I hope that you learned this. If you have any questions or comments about the video, please leave them in the comment section under this video. And see you next time here on Mr. Francois Physics.